Okay, ji, Bismillah Rahman Rahim. Welcome to the second lecture of artificial intelligence. Last time we discussed different definitions of artificial intelligence and then a brief history of AI and then state of the art work going in the domain of artificial intelligence. Today we will be discussing uh, about different agents uh, used in artificial intelligence are discussed in the artificial intelligence field and about the environment where agent will be deployed and agent has to perform certain tasks in that environment. So how to formulate the environment, how to discuss different aspects of the environment, and then different types of agent. There are several types of agent. So at the end we will be looking at the types of agent. So the agenda for today's lecture is to get an idea of what exactly the agent is and then how the agent operate in an environment, then nature of environments and different properties of the environment, and then a basic skeleton of an agent design, that what are the parameters and what are the features we have to look at while designing an agent, and then in the last, basic agent types. So we are aware of the agent that is looking like this gentleman. We say this is an agent of particular agency. So now in AI, agent is a bit different thing. Now this is the formal definition of agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. So there must be three or four important things in agent. There must be an environment for an agent, and there must be some sensors in an agent where using those sensors the agent can get, perceive, get input from the environment or perceive the environment. And then there must be some actuators that can be used to perform certain actions or give response to the environment. So you can see in this diagram there is this environment and this is agent. So there must be some sensors, and the sensor may be camera and maybe pressure sensor, etc., heat sensor. So from environment through this sensor it accepts an input, and we call that input as percept. So the percept is received via sensor that is added in body of an agent, and then agent response through actuators, and the response is in the form of an action. So this setup is what is called agent and its environment. There are different examples of an agent. So the agent could be a human agent, it could be a robotic agent, and it could be a software agent. So if we consider the example of human agent, now in that agent eyes and ears and other organs of the body are sensors for human agent. Now hands, legs, vocal tract and so on, they are the actuators. So from eyes, I mean the sense, all the senses, all the five senses are the senses. You can look at something, you can hear something, and then you can feel something. So this is these are the ways you get input from the environment. Okay. Now you have hands. You can use these hands to act in response to the feedback you receive. You can say precisely a percept received from your environment. Okay, so for human for human agent, hands, legs are actuators, and eyes, ears, and other are sensors. For a robotic agent, cameras, infrared range finders are sensors, and various motors are actuators. Now, for the software agent, okay, the agent may be in a form of a program or software. For a software agent, keystrokes, the file contents, and network packets can be considered as sensory inputs and acts on the environment by displaying on the screen, writing files, and sending network packets. So those are the actuators, and the first one is sensors. Take care where you through sensors you actually get input from the environment, and through actuator you give response to the environment. So keystrokes, file contents, network packets, they are kind of sensors where you receive message from the environment, and writing to a file or sending packets to network. This is what you deliver a message, a response to the environment. Okay, now there are different terminologies that we will be using throughout this course and this lecture. So you need to have a very clear idea and precise definition of each of these terminology. Okay, the first of the terminologies is percept. Okay, the agent's perceptual inputs. So anything it receive, it receive from the environment is percept. Percept sequence, the complete history of everything that agent has perceived. So now percept is a single percept, a single input, and percept sequence is number of percept that have been received since the start of the environment. Now, agent function. So the responsibility of the agent function is to map a given percept sequence to an action. So now this is the agent function who is responsible to decide a specific action for for a particular percept sequence. So for example, uh, if percept A and then percept B receive, then this particular action should be performed. Now this task is uh, what has been done by the agent function. Now this is there is a different thing that is what is called agent program. Now agent program runs on the physical architecture to produce F. Okay, agent program is the concrete implementation on the hardware. So the concrete implementation of agent function on the hardware is called agent program. So agent is, so what is agent? Agent is nothing but architecture plus program. So there must be hardware, and on that hardware there must be program. So the combination of this hardware and this program is called agent. Okay, so let's consider an example to get the idea that how we express percept, percept sequence, agent function, and agent program. So the example is vacuum cleaner. So I mean, the vacuum cleaner is an agent whose task is to clean a place, a box, a room. Okay. So this, let's consider this environment. Now the environment is a word, you can say, the particular place where there may be some clean places, some dirty places, and there is an agent. The agent is, we have named this agent as vacuum cleaner. So its task is to clean the dirty portions of the word. Now this particular word has just two locations. Okay, so let's I mean make it simple. Now the word has just two squares, square A and square B. Now this is our environment. Square A and square B collectively uh, is our environment. Now percepts location and state of the environment. This is what the agent would receive. For example, where the agent is and the state of the environment. If a, so this is percepts. This is what the agent will receive. It will receive that where does it stand now, and what is the situation, the state of the surrounding, whether the surrounding is dirty or clean. Action. Now the actions that the vacuum cleaner or the agent will perform are: it can move to left, it can move to right, it can suck the dirt to make it clean, and it can do nothing. So these are the actions. Now based on the actions we can design a function. So the function, if the perceived sequence has just a single input, that is, now the location of the agent is, it is in if I can show you. Okay, let me show you a diagram of this. The diagram is missing. No worries. So okay, now here you can see uh, that simple agent became cleaner. So now if we can see if the vacuum cleaner, the agent, is in location or in box A and it is clean. Now the agent should move to right to box B. If it is in box A, or you can say a square A, and it is dirty, now the possible action is to suck. If it is in B and it is clean, then the square has to move to the left, and if it is dirty, then the agent has to suck to make it clean. Okay, and then different combinations of the possible states or percept sequence, and these are the actions. So now the agent, what the agent does is it saves this table, and whenever it receives an input, it matches to the sequence, I mean the percept sequence on the left side of the table, and then decide the action what is written in front of that sequence. So this is how the vacuum cleaner operates. So this is the implementation of this function uh, will be considered as agent program, and this is agent function. These are the actions, and these are the percepts. Okay. Now, okay. Now, we need to define rationality for agent. We have seen different definition and concepts of rationality or thinking rationally. Now we need to make it more precise that what a rational agent would be. So an agent should do the right thing based on what it can perceive and the action it can perform. So based on the set of actions and set of percepts, the agent should do the right thing. And if a particular agent does this thing, then we can say that that agent is rational agent. The right action is the one that will cause the agent to be most successful. And now the rationality is the maximum benefit. Now let's modify the definition of rationality. An agent should be considered rational if it stays more successful. It does the actions that make it more successful. Now this success, how will we measure this success? This is a different story, we will cover it in this lecture. Performance measure. An objective, there must be an objective function or objective criterion for success of agent's behavior. So there must be a performance measure, a performance function that will measure the success of an agent. Let's consider the example of vacuum cleaner. So if we consider that the success for the vacuum cleaner, which is clear from the description, that the success of the vacuum cleaner is to suck the dirt and clean a particular square. So now we can design a performance function or objective function or a performance measure that can measure its performance. So we can say that if a square is clean, we will give +1 credit to the vacuum cleaner. So now at the end we will see if the score is high, we can see this is a rational, this is an agent that is more closer to the rationality, because it is more successful, it has done what is required and what it has been told to do. Now the general rule is measure what one wants rather than how one thinks the agent should behave. Okay, if you want to design a performance measure, so don't focus on how do you want to achieve it, just focus on what you want to achieve. So you want to get a clean world, a clean environment, then your focus must be while designing the performance measure or performance function, your focus should be uh, on the clean environment. You want cleanliness, so you should give credit to the agent if it acts accordingly the way you want. So this is the generic rule for designing a performance measure. Now let's now give a formal definition based on the uh, terminologies we discussed in the previous slide. Definition: for each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. Based on the knowledge provided to the agent and based on the knowledge what it has already. So based on this knowledge base, the rational agent should select an action in response to a particular percept sequence that maximize its performance measure, or you can say performance objective or performance score. A simple agent that cleans a square if it is dirty and moves to the other square if not. Is it rational? For example, let's consider the previous example. If there is an agent, okay, and the agent clean a square if it finds it dirty, and if not, it move to the other square. So, do you consider it's rational? There are this the answer of this question depends upon certain other things. First, we need to say what the performance measure is, what is known about the environment, and what sensors and actuators the agent has. So we need to get answer of these questions. Once the answers are received, then we will be in the position to respond to this question or decide whether the agent is rational or not. So now let's decide whether the uh, whether the agent that is discussed in this sentence is rational or not. Assumption. For example, the performance measure, we have a performance measure, 1 point for each clean square at each time step or a lifetime of 1000 time steps. For example, if we have 1000 time steps and for each clean square we reward +1 to the agent. The geography of the environment is known a priori, but the dirt distribution and the initial location of the agent are not. Okay, so we can see that we are given an environment. There are two squares and B. The environment is clear. There is a performance measure. Okay, there are possible actions: left, right, suck, and no other option. Or you can say do nothing. Now, and the other thing that is in addition, the agent correctly perceives its location and whatever that location contains dirt. So, I mean, there are proper sensors in the agent. It can clearly perceive, correctly perceive. So, if both of all these things are uh, stay there, there is a performance measure, there is a clear environment, and there are some actions, and there are things using which the agent can correctly perceive the environment. So if these things are there, now then it can be claimed that under these circumstances the agent is indeed rational. Its expected performance is at least as high as any other agents. So now, if these things are clear, then the agent is rational. It has a performance measure which the agent will try to maximize. Okay, now the same agent would be irrational under different circumstances. So we are going to see two examples where the similar uh, agent will become irrational. For example, once all the dirt is cleaned up, the agent will oscillate needlessly back and forth. So let's say uh, if for the same, let's say the agent has cleaned both the squares in just one go, I mean just two steps. Clear this, then went to the left and then clean that and then back. But you have set steps till, I mean number of steps 1000. So once all the dirt is cleaned up, the agent will oscillate needlessly back and forth. If the performance measure includes a penalty of 1 point for each movement left or right, the agent will fare poorly. A better agent for this case would do nothing once it is sure that all the squares are clean. So if this thing is not included in your design of the agent, then your agent will perform poorly because it will move back and forth without doing anything. So that is not rationality. That is not the right thing that the agent is doing. So for such setup, the agent is not rational. You need to incorporate another uh, action, that is do nothing. If there is not do nothing in your setup, then the agent is not rational, it is not doing the right thing. Example 2. If the geography of the environment is unknown, the agent will need to explore it rather than stick to square A and B. For example, now the environment is not just these two squares AB, rather than the whole world. In that case, the agent will try to explore and try to make mistakes. I mean, try to uh, go against the rules to first explore the whole environment. In that case, the the agent will not be a rational one because it is not doing the right thing. Sometimes during exploration, it may uh, do a stupid thing because it doesn't have any idea of the environment. So in both the cases where the environment is not clear, where you have not the actions are not properly designed, then there is possibility that your agent may not remain rational. So that was all about rational agent and agent definition.